Resume recording. There we go. So if you want to look at something that we talk about today, take more time with it. And our goal for the day is to come out of this class knowing one or two things that we didn't know before the hour started. That's all it is. And maybe pushing our way a little closer to understanding something else. All right? Who's got a question? And say your name and say hi or whatever. I mean, I can see your name, but save me clicking it and make that way everybody can start to learn each other's names. I do have one announcement. We have this room, and I don't know if you can see that door, but that goes into another big classroom that nobody's using this block, which means somebody's going to be at this board, a group of three there, another group of three there, and then we have the other room, right, for 9 people, which I think is we're about 18 in the class. So we're going to be able to do a lot of interactive. I think we'll put one of the boards as being, hey, I really want to pick up the pace here. I think people should work together that are kind of working at the same pace. I think that works best for everybody's learning. All right. And give you a chance to, we'll talk about that on Monday. All right, let's start the class. Who's got something that they're trying to push their way through to understand mechanically and intellectually?
I got a quick question.
Go ahead.
Could you go over number 18?
If you tell me what it is.
Yeah. It's 2 over 4 plus 3i.
Sure.
Thank you.
Yeah. Now, mathematicians do not like to have irrationals or imaginaries in the denominator. With the advent of the computers now, how far along they've come, this is a skill that'll probably disappear. Okay? I'm still teaching it because the kids tell me it's on the SATs and achievements. All right? Otherwise, I really no purpose in this. The only time you do conjugation is in calculus, and that's to find the rate of change of the square root function, and you conjugate the numerator. All right? But just for mechanical practice. And let me explain why ancient mathematicians wouldn't like something like this. So let's divide pi by 2. Let's divide pi by 2. I think you'd come over here and you do 2 goes into 3.14, I think 15, da, 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 da. And you can get a feel for that division, yes? But let's look at 2 divided by pi. Okay, so I got the number 2 with lots of zeros, and I'm going to do divided by pi, 3.141, right? Messy. Okay, so that's why we rationalize the denominators. All right, so what's the mechanics of this? Multiply by 4 minus 3i, multiply by 4 minus 3i. For people who need a push, do it in your head. Tell me what the answer is in your head. Without any writing, see if you can tell me what the answer is. I already know what it is just by looking at it. Okay.
Minus, can I say it?
This one over here?
Yeah.
Sure, what is it?
8 minus 6i over 25.
You got it. Very good. Okay, so you just did something effortlessly because you did a little effort on your own, right? I'd like to encourage that. All right, so folks who can't do what Teresa just did, I believe, yes, Teresa? Pretty hard learning names right now when all I see is a little pixel and my eyesight isn't good. All right, so let's do this out. And then I'll give you another one over here. All right, so distribution, yes. 8 minus 6i. 4 times 4, 16. Middle terms cancel. Minus 9i squared. And what do we say minus 9i squared is?
9.
Positive 9, right? There's your 25. All right?
I have a question.
Yeah, well, on this?
Yeah.
Go ahead.
How did you get the 4 minus 3i over 4 minus 3i? Like how?
Well, what is good? Great question. Who's asking that? I gotta get names down. Julie.
Julie.
Well,
yeah.
I know you. All right. All right. You tell me. Tell me what we got a fraction here, right? 2/3. If I multiply it by 1, what have I got for a fraction? Still 2/3, right?
Mm-hmm.
Okay. Well, what is what is 4 minus 3i divided by 4 minus 3i? What's that equal?
1.
Yeah, I'm not changing the size of the fraction. So I'm not changing whatever we have over here, 2 over 4 plus 3i. I'm not changing this amount at all. I'm not changing it because I'm multiplying it by 1, but I'm changing what it looks like. Okay, and so what it looks like, 8 minus 6i over 25, well, now I've got a nice number that divides into something. So it has a better feel to it. Like, what do you have for a feel? When I say, okay, I divided by 2, 2 divided by I. Do you have a feel for that? I've been teaching 40 years. I don't have a feel for that, right? That I have a feel for. Whatever I is, I got half of it. Does that make a little sense? So
Yeah, it does.
that's kind of why we're doing that, okay? All right, who's got another question? Is that okay? Good enough practice? I forgot who
I have
asked
a quick
for that.
question on that one.
Yeah, go ahead.
Why is it 8 minus instead of 8 plus?
Well,
Or
if
sorry,
I'm gonna get something nice here, I gotta get rid of positive 3i times 4. What gets rid of positive 3i times 4? Positive 3i times, well, I said that poorly. If you multiply this out, the denominator, 16 minus 12i plus 12i minus 9i squared. That's what you get, yes?
Yeah,
What happens to the middle terms every single time?
they cancel out.
They cancel, they're gone. And what did we say I squared was?
-1.
And -1 times -9 is +9. Now we have a nice number in the denominator.
Okay.
All right, so what's the conjugate of a plus b?
Of what?
What is the conjugate of a plus b?
B minus A?
A minus b,
A minus B.
okay? Can anybody tell me where you've heard the word conjugate before?
Spanish?
Where do you hear the word conjugate?
Language.
Language, yes, right? Conjugating verbs, conjugating whatever, right? You're changing something a little bit, all right? I haven't changed the amount of the fraction. I sure am changing the look, all right? So somebody gave it the name conjugation. If somebody wants to look that up on Google, where the word came from mathematically, maybe share it with us. Who's got another question?
Hi, this is Fred, and I'm not sure how to do question
Sorry, I
23.
didn't hear. Fred?
Yeah.
Okay, go ahead. What's your question?
Question 23. I
Yeah.
don't know how to do it.
What's 23?
Write the equation of the exponential function that passes through the points 9, 8 and 12, 16 and has a horizontal asymptote of y equals to 6.
So y equals 6. Yeah? And then the first y you gave me was an 8, yes?
Yeah.
How'd you get from 6 to 8? How would you get from the number 6 to the number 8?
9 over 6. 8 over 6.
No, just here, I'm at 6. I'm at 6 on a number line. I go to 8. How did I get there? Anybody?
2.
Add 2.
2.
The next number wasn't 8. I forget the next y value. What was the next y value? You gave me another y value, didn't you?
16.
16. Well, how do you get from 6 to 16?
10.
Oh, so you didn't add 2 that time, did you? You added 10. And what was your first x value?
9.
9. Okay, 9. Well, yeah. I think I'm going to make something that makes you plug in a 9. Let's plug in a 9 right now. What's 9 minus 9?
0.
0. What's anything to the 0?
1.
1 times 2
2.
plus 6.
8.
Do we want a 9 to convert to an 8?
Yes.
I guess we just did. Is this exponential growth always bigger than 6? Are all of my y values above 6? Are all of these
Yes.
y values bigger than 6? Yes. And what's the next x you gave me?
12.
How far is it from 9 to 12?
3.
That's that function. Now, I'll take you through that process again, but from a different perspective. And then we'll look at it from the different perspective. Because if you can get the data from an equation, then you should be able to graph if I give you the equation. All right, so let's try that. Get a little practice. And for those of you who, if you want, if you want me to push it, I'll push you over here. But you got to tell me. All right, so graph this. Y equals, how about we do 10, 1/2 to the x minus 4 over 20 plus 7. Let's see if you can sketch that. Raise your hand when you're done.
We're gonna graph that, right?
Yeah, just get a quick sketch. Anybody done yet? I had a kid race me. I think I told you, a kid raced me about graphing logs in 6 seconds. That was pretty good. Anybody done? I'll bet half of you will be done in this amount of time, a month from now. All right, should we do it together and then try another?
Yes.
Probably. So growth and decay. Growth and decay. What kinds of things change exponentially? Anything out in the real world that you know changes exponentially?
Coronavirus cases.
Yeah, at times it does, yes. Unless you flatten the curve, right?
Isn't it?
What else? Somebody was speaking. Say again?
Stocks?
Docs?
Stocks.
Docs, maybe,
Stock exchange?
maybe, yeah. I'll tell you one thing that changes exponentially, radioactivity. You ever hear of a half-life? Right? What a half-life means is that if you started with 100 grams, say, of uranium, I don't know how long the half-life is, but maybe it's 17,000 years, you got 50. In another 17,000 years, you got 25. In another, so on and so forth, until it goes to 0. Okay? The problem with radioactivity is you might not be able to live in the valley until it gets down to 1. Right? That's why that stuff's so lethal. I think corn, by the look of it, I think corn grows exponentially for a certain while. Right? I mean, just watch that stuff pop up. Populations sometimes grow exponentially, and there's other things. All right, so let's graph this and see just how hard it is to graph this. I'm guessing that you'll be able to graph this the same way you graph the equation of a line with a little practice. All right, so we're cutting something in half. All right, let's say my height gets cut in half. Cut in half, cut in half, cut in half. How much is going to be left of me if I cut myself in half 100 times?
Not a lot.
Nothing, right? This part of the equation is going to 0. So all of my y values are what? Bigger than 7. Okay? Everybody okay if the base of the exponential function is less than 1, then we have decay. And
Wait, I'm sorry, repeat that? What?
if the base of the exponential function is less than 1, we're nibbling away at something.
So it's going to be a slope
So
downward?
it's disappearing. And I'm going to 7.
Yeah, but
Yeah,
the
it's gonna slope down.
is moving downwards.
Yeah.
I don't know, something like that I wrote. Yeah, something like that. It may not be the exact numbers. I didn't hear the last comment. Okay, I don't know if there was still a question. So from left to right, you read graphs from left to right. What are my y values doing? Decreasing, yes?
Yeah.
And at a half. So here's an initial amount. I'm going to call that an initial amount. And what's going to happen to that initial amount?
It's gonna cut in half.
Every 20 years, it's going to cut in half. That's about half the size of that. And it's going to take 20 years for that to happen. What number is being begged to use? What number should I plug in right now?
4.
4.
Oh,
I want 4. 4 minus 4 is what? Don't be afraid to
Zero.
make a comment that's not correct. Say it out. You know, shout it out. That's the only way you're going to learn. 4 minus 4 is what?
0.
And anything to the 0 is what?
1.
1.
1. That means I have an initial amount of 10 units. That's what this is. That distance from 7 up 10 is going to go to 17 if I pick the number 4. And then what's this amount going to be? What's that distance going to be?
5.
It's going to be 5. It's going to be half of that. 5. Okay, so what is 5 plus 7? 12. If I pick the right number. Now, when am I going to do 1/2 times 10? Whenever this thing here is equal to 1. If I make that equal to 1, then I've got 5 plus 7 is 12. Now, how am I going to make x minus 4 over 20 equal to 1?
X equals
24.
24.
24. Okay? Now, let's say I give you this graph. Oh, God, I can't remember what I had. No, I had 17. I remember now. And I had 12. That's correct. Okay? So now, how would we go backwards? What would we do to write the equation of that graph? Well, what's step 1?
Y equals
Y equals what?
7.
7. Okay, you're 1/4 of the way there because there's only 4 things you got to do. What's the next step?
The change in X over change in Y. Or
Well,
change in
actually,
Y.
that's going to really refer more to the linear. The next step, but nice try. The next step is finding that first initial jump. Finding that initial jump. Can you tell me what that initial jump is?
10.
10.
10. Right? And then we look at the second jump. The second jump, right? The first jump is 7 to 17. That's where that 10 is coming from. The initial jump is 10. And then the next one is 7 to 12, which is 5. And the base of an exponential function is the second divided by the first, 5 over 10. And now we've done everything with the y values. Now we got to turn our attention to the x. How am I going to highlight the number 4? X minus 4. And how much has it changed from 4 to 24?
20.
Okay,
I have a quick question.
go ahead.
So how did you get 24? How did you get 24 there?
This one,
Yeah.
I want this thing to equal 1.
Okay.
What's
Oh, I see.
24?
If you put if you replace 24 for X,
Yep.
24 minus 4 is 20, and you get 1. All right, got it.
And
Thank
I
you.
know if you give me a base and I put a 1 on it, I know the answer to that every time. What's 3 to the 1?
3.
I guess your brain's working. That means you can do the math.
Got it.
Okay.
Thank you.
All right. Is that enough practice for that, or do you want one more?
Can we do one more?
Sure. I was hoping you'd say one more. Name that tune.
Do we need to solve it with E notation, or can we just solve it?
Yeah, you've had experience with it, Aaron, so you know where I'm headed with this.
Do we have to solve it with E notation, though?
I don't know how to answer that. I just want to develop what this is so that we can begin working with it. Yeah, I would say you should convert it, right? You're at the stage where you should convert it. All right, so what's this equation? Where do I start with?
Y is E of X. maybe?
Yes, we're going to get there, but let's see how. Let's see how we do it. Let's go through the mechanics. All right, so what do I say? How do you
There's-
start writing an exponential function?
There's 2.71. So if you look at the Y values, the
Step
base.
one, I want to go the
Oh.
real mechanic, the same way we did the last problem. I want to do it here.
So the number would be 1, right? Because
What's the most important y value in an exponential function?
The initial
the
amount.
initial the initial ascent,
Nope. Nice try, you're getting there.
initial jump, you said?
I have 3 y values. I have 0,
Y equals
1,
0.
2.71. What is the one that's most important?
Y equals
Minimum?
0.
The
It's just like
asymptote.
said 1.
It's actually this one right there, 0.
Yes.
Right? Because every other y value is where?
On that axis.
Above it.
Where are all the other y values in reference to this?
Above it.
Above it. Okay? How much is my initial jump? Somebody already told me that one.
2 points.
1.
1. What's my next jump?
2.71.
So 1 plus 1, 1, 2.71 takes care of the y's. What am I going to write for the x's?
It's just X.
X minus 0 over 1. Can we agree that there are an awful lot of unnecessary symbols in that? Do I really need to write 0 in this case?
Nope.
Do I really need to write a 1 times something?
No.
No. Do I need to divide something by 1? No.
No.
No, no, no. This is the graph of 2.71 to the x. Okay? 2.71 to the x. And therefore, Aaron said we have a new name for that, and what is it?
E to the x.
E to the x. So this is approximately e to the x. That's the most important graph that we are going to study this semester. Now, who needs a little push on that as to why it's the most important? Anybody want a little push? You can work on this on your
Yeah.
own for 3 minutes. I'd like to know at what rate it's changing right here. I'd like to know at what rate. And I'll come back to it and answer that for you. But if you want to pause and think about that, that's great. Okay? So, since it's the most important graph that we're going to work with, I think it's really important to know some values. And I've asked you to memorize these values. I don't want 1.7 and 1.1. Now, I know, I assume Aaron and Elliot, you remember those?
Yep.
Okay, somebody else. Who's
And me.
Clarice, you memorized them too, didn't you?
Yeah.
Yeah. Do you remember some of them? If you do, don't chime in. Anybody look at the memorization sheet and know any of these yet? All right, Aaron, Clarice, Elliot, I don't care, chime in. Either 1.1?
1.1 or negative 1.1?
Either one.
3 and minus 3.
3 and,
-3.
One third.
Oh no! No! It's
1 over
points.
3.
Oh,
One third.
I was gonna say
0.7.
0.9.
2.
1/2.
0.
1.
Okay, so what was the asymptote? Y equals 0, and all of these points are on there. Okay, and I'm asking you to get familiar with those, because if you get familiar with those, you will, when we start looking at the rules of logarithms, you're actually going to know where they come from. Otherwise, you're not. So try to get familiar with those. Does it make sense that 2.71 to the 1 is 2.71, and 2.71 to the 1.1 is a little bit bigger?
Yeah.
Okay? Now, I didn't know those numbers until I looked them up on Google. And my understanding of this function has exponentially improved by looking at those numbers. because it has taken me for a nice ride through, oh, that's how you do this. Oh, that's how you teach that. Oh, that's what this function's about. Okay? So you want to learn those. The easiest way to learn them is to, just look at them for a few seconds each day. And you'll get them down. We'll be working with them. Did we do word of the day in this class? We got to start word of the day.
No, not yet.
Oh, we got to start it. So let's do efface. Anybody know the definition for efface? Well, let me erase that if I could. Get rid of it, just so that you're thinking about efface. Anybody know the definition of efface?
Remove from a surface or make oneself seem inconspicuous.
That could be a variation, but it means to erase, to get rid of.
Erase, yeah.
Okay, so efface is to erase, and I just erased it. All right, and to keep up with the other class, I'm sorry, you're doing 2 words a day. Laconic. Can anybody share a few words on the word laconic?
Lack of interest in topic.
Yeah, that's not bad. So you're studying your SAT words, or it's really to say something in a few words. Laconic is not speaking a lot. Okay? So that's why I said, anybody want to share a few words on the word laconic? Okay? So those are our 2 words of the day. We'll get 1 more tomorrow. And I'm doing this for a particular reason. And the folks I have, Clarice, Aaron, Elliot, know why. The rest of you don't. But you will. All right? So there we have it. We're starting our work with e to the x now. What's up? Something else from the homework? Did anybody find the rate of change at 2.71? I'll come back to it. Maybe I'll leave it as a challenge. Who's got something from homework?
I think like this question kind of relates to what we just went over. Could we go over 34?
If you tell me what it is.
Yeah. It's write y equals 2 to the x in approximated e notation.
It does have a lot to do with this, yes. So e notation, okay? Clarice, Elliot, Aaron, don't answer. What's the exponent you put on top of e to get a 2?
We said 0.7.
0.7. So e to the 0.7 is approximately 2. It's really 0.69, and then there's some more stuff, right? But I'm just saying 0.7. All right. So 2 to the x could also be approximately written as, can you think of a way to write the number 2 using e?
Yeah, e to the 0.7.
Oh, I think it's e to the 0.7. You put these in your grapher, you're not going to see any difference in the graphs. They're almost identical. I think NASA uses e to about the 5th decimal place for all their calculations. If they do e and run it out 5 decimal places, they're sending people up in space. So not a lot of inaccuracy. Okay, so does that make a little sense at all?
Yeah.
Where do you think I got 0.7 from? Where do you think I got e to the x equals 2? Do you have a sense? Anybody? Not Aaron, Elliot. I know we've done this, Clarice. Can anybody tell me how to solve that equation? Do you know the inverse operation?
Log.
I'm looking for the value of an exponent, right? What finds the value of exponents? What operation?
The
Logs?
natural log of 2.
Logs. Yes, this is the natural log of 2. N for natural, L for log. That's the same thing as this. That's the question that is asking. And that's a button on your calculator. You can type this right into Google, just like that, L in a parentheses 2, and it's going to give you 0.69, da, 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 da. Okay, and that's the only way you're going to find those numbers. You want a challenge question? Yes, you do. Without a calculator, what's the L in a 6? Anybody tell me a way to do that without a calculator? Who's got a hand up? Emily, you know how to do that without a calculator?
We were doing it last year. Isn't it like square root, like 3 root 2 or something?
Not quite, not quite. Not quite sure what you're after there. 3 root 2. Sounds more like trig. I'm not sure. Not sure what you did last year, but nice try. Aaron?
Is it like around 2.1 or 2.2?
I think it's 1.8, just looking at it. Anybody think of another way to write 6?
3 times 2?
Oh, let's do that. Let's do 3 times 2. Anybody know another way to write the number 3?
ln of, or e to the 1.1.
E to the 1.1, you're right. 3 is e to the 1.1. Anybody know how to write the number 2?
E to the 1, you mean e to the 0.7?
Oh, e to the 0.7. Anybody know the rules of exponents here?
And add them.
Okay, approximately 1.8. So you added 1.1 and 0.7, yes? I think that's what you added, yes? And what is 1.1? Oh, I think that's the ln of 3, yes? What is 0.7? Well, I guess that's the ln of 2. Geez, you know, I don't know. I kind of see a pattern there. I didn't have any intention of showing you that today, but that's where the conversation led us. So let's get back to the more basic problems that you have been working on. Go ahead, ask something.
I have another equation one.
Go ahead.
It's write the equation of the quadratic function whose vertex is 4 and 7, and also passes through the point 10, 6.
Okay, we'll do a couple of these. 4, 7. Can you tell me what I should write if 4, 7 is the vertex?
X plus 7.
Anybody? 4, 7 is the vertex. What can I write over here? Y equals, what can I write?
7.
X minus 4
4
squared.
plus 7.
X minus 4 squared plus 7.
Plus
Is that okay? And what's the next x value?
The next x value is 10.
10. And when you put 10 in here, you get 36 plus 7, yeah? If I drop a 10 in right now,
Yeah.
36 plus 7. Okay? But I don't want, what if I don't want 43? What if I want King Kong? What if I want King Kong? What do I write here? This number doesn't work, does it?
No.
I got to get rid of it. Can anybody remember from yesterday's class how we
Oh,
get
you put
rid
it
of
in
it?
the denominator.
1 over King Kong.
Yeah, you put it under here. You put it under here. 36. What happens to the 36s?
Goes away.
Gone. And I wanted King Kong. Oh, well, it's a little tougher. I got to do King Kong minus 7 if I want just King Kong. Actually, I have to get rid of that. I didn't want to do that to you. So let's go back to a number. So 10 gets me what? Let's say 200. Well, how far is it from 7 to 200?
193.
Then let's put 193 here. You ready to try another one?
Yes, sir.
Okay. I'm going to do a canned one so that we can see the numbers work a little bit. So let's do 2 comma 100, and let's go to 7 comma 150. Okay, that's a real canned one, and then we'll play with it and come back to the graph. Okay, we'll create the equation, and then we'll erase the graph and come back to the graph. All right, for good practice. That's a real good question. You're all asking very good questions. Now, if you didn't do that on the last problem and you did it on this one, then you're learning. Okay, I don't know if that happened to anybody. And if you didn't know what to divide by on the last problem, but you do now, then that's success. All right? Well, if I go from my first x to my second x, how much have I moved to the right? 5 units.
5.
If you square 5 units, how much do you go up?
25.
25. Is 25 plus 100, 150?
No.
No. So we don't want to go up 25. We want to go from our first y to our second y by going up how much?
50.
Okay. Can we agree that that's a pretty integer-friendly equation?
Yeah.
All right, so let's write it. 2x minus 2 squared plus 100. Would you please put that in the ax squared plus bx plus c format? I'll give you 30 seconds to put that in the ax squared plus bx plus c format. I'll give you a head start, and then I'll just write it. Tell me if I did that right. 2x squared minus 8x plus 108.
Yep.
Okay, we've got confirmation that that's correct. Would you please now graph? See if you remember how to give a sketch of 2x squared minus 8x plus 108. Let's do it together so we can get more questions. So what do I start with?
Vertex.
Y-intercept.
Y-intercept. 108. Am I going up or down from there?
Down.
Down. Minus 8. Down. Minus 8. Steeply going down. Cup shape up or down?
Up.
Up.
Cup shape up. Is my x value positive or negative?
Positive.
Positive. 2 goes into 8. 4 cut in half is 2. Yes?
Mhm.
So let's drop a 2 in. That gets me 8 minus 16 plus 108. Do I like those three numbers?
Yeah, they're
Yeah, because I got 2 to 1 in opposite, so I have not made a mistake. All right? Is somebody trying to get in here? I can't see. All right. So we got minus 8 plus 1. Is that 100? But is that right? Is that the same graph we had before?
Yep.
Can you tell me the A term using this graph? Can you give me the A term and how we get it?
2.
Okay. I've gone back 2, and I'm going to square that, yes? To get from my first x to my second x, I went this direction 2 units. And if I square that, I should go up 4, yes? How much did I go up?
108.
I went from 100 to 108. I went up 8 units. And what is 8 divided by 4?
2.
The same way over here, I went to 7, I went over 25, and I went up 50. This is telling you to double the squaring process. So I don't care what coordinate you give me. I'm going to get that ratio of change, which comes from rise over run squared, as measured from the vertex. Why that's not in the textbooks, I have no idea. Okay? So are we okay? Any better with that? Follow that? Okay, some thumbs up. Who's got another question? I got a little quiz for you. Would you please answer the following? Would everyone please do the following? First question, 5 over 4 minus 7i. Would you do that one? Would you please sketch y equals 2e to the x minus 3 over 4 plus 5? I'd like you to sketch that. Would you please solve e to the x equals 7? Please solve that. Trying to think. Would you please give me the equation for this exponential function? Yeah, try that. I don't like that number. Let's just do 16. Okay? And would you please write this equation? Okay, 5 problems. Can you see the board all right? That better? Try those 5. I'll even do one more. Everybody have enough time to do the first one? Any questions on the first one? Right, multiplying by 4 plus 7i, 4 plus 7i. And I took a 5 out of every term, right, just to reduce the fraction. Trying to give you enough time to do each problem. Have you gotten stuck on the second one or are done?
Yeah, I'm not sure what to do in the second one.
Tomorrow's speed graphing e to the x is a video that will give you a real good chance to do what I'm about to do for you now. When I do e to the x, I do it in such a way that there's an initial amount. I'll just call it my initial amount, my A1, and my A2 is 3 times that size. Every single time I do this, I find the initial amount. Where's the initial amount? Right there. So this is going to go up 2, this is going to go up 6, and y equals 5. Okay? Now, how do I make that happen? Well, if this is going to go up 2, then this thing has to be 1, yes? Doesn't that have to be the number 1? And e to the what is 1?
X.
E to some number, right? E to what number gets me the number 1?
1.
E to the 1 gets me 2.71.
Oh, wait.
Zero.
0, 0,
Zero.
0.
Can somebody tell me how to make this fraction equal 0?
X equals 3.
X equals 3. So if I let x equals 3, then I'm always going to get this number. If I make the exponent work become 0, I'm always going to get that. Okay, so this is 2 on top of 5. That's 3/7. And I know it's exponential growth, yes?
Wait, how did you get 3/7?
Let's put a 3 in and do the math. 3 minus 3.
0.
0 divided by 4.
1.
0.
0. E to the 0.
1.
1. 1 times 2.
Negative 1.
1 times 2.
Oh.
2,
Plus 5.
7.
That's how I got 7. Is that all right? Now, what does a number like this do? It usually changes my x by 4, and that usually is very helpful, but not the way I do it, because I like this. Are you able to do that calculation right here? Do you know what e to the 1.1 is?
3.
3 times 2.
6.
6 plus 5. Remember I told you I'd add 6? 6 plus 5 is what? Up here, 11, yes?
Yes.
Do you think you can make this equal to that? Do you think you can figure out how to make x minus 3 over 4 equal 1.1? Can you do that in your head? What's x?
7.3.
7.4, right? Isn't it going to be 4 times 1.1, which is 4.4? And then aren't you going to add 3? So I now know that 7.4 should work. Let's put 7.4 in here. Let's put 7.4 in here. 2e to the x minus 3 over 4. 7.4, I think is what I said, right? What is 7.4 minus 3?
4.4.
4.4. What is 4.4 divided by 4?
1.1.
1.1. What is e to the 1.1?
3.
3. E to the 1.1 is 3. What is 2 times 3?
6.
Plus 5.
11.
Okay? Now this is day 1 for you, right? Day 1. Got to do this 4 days. Takes practice. You think, you ask yourself now, do you think if we keep talking about this every single day till the end of the term, do you think you're capable of learning that?
Yeah.
I think so too. Okay, so let's just do one more on this since it's such an important function, right? And if you've already got this down, you can try to do the L in the 3/2. Okay, but this is such an important function. So let's graph 10 e to the x over 5 plus 6. All right, see if you can graph that. 10. I guess I'll do it over here. Okay, see if you can graph this, and I'll move this over so we have some space. Okay, give that a go. Guys, I think I erased half of what I wanted you to do over here. Jesus. Oh, God, I forgot what I gave you over here. Oh, you'll give me those numbers in a minute. When you're done, let me see hands. 1. Anybody else finished yet? How many people totally stuck? Okay, thanks. Okay. All right, so what's the first thing I can write? Let's see how far along you are. What's the first thing I can do with a pen?
Asymptote is 6.
Y equals 6. Anybody tell me what my initial jump is?
10.
10. All right, so I'll make this 10 units, okay? Anybody tell me what my next jump's going to be?
30.
30. 3 times that, okay? Provided I pick the right numbers. What's the first number I'm going to pick?
0.
0. 0 divided by 5 is 0. What is 10e to the 0 plus 6 equal to?
16.
Is that 10 plus 6?
Yes.
16. 0 gets me 16. So actually, that's the y-intercept. Okay, so this is the y-axis. Origin's down here somewhere. Okay. Can somebody tell me what would be a nice number to put on top of e? If I want to triple it, what would be a nice number to make this?
1.
5.5.
I'd like it to be 1.1, wouldn't I?
Yeah, 5.5.
Okay, so I think 5.5 is a good choice. So 5.5. 5.5 divided by 5 is?
1.1.
1.1. Can anybody do this math? Can somebody tell me what e to the 1.1 is?
3.
Times 10.
So it'll be 30.
Yeah, it's going to be 30 plus 6, 36. 5.5, comma 36. We know it's exponential growth, asymptotic behavior. Okay? Were you able to follow? First stage of learning is to follow. Were you able to follow that a little bit? You'll be able to follow it better tomorrow when you look at the video. And we'll be doing some more e to the x tomorrow. I forgot how to do this. Can somebody tell me how I get this answer? Can somebody get it off the calculator, please? And give me the decimal? 'Cause I don't know what that answer is. So can somebody go to the calculator and
I
tell
think
me what
it's
that is?
log
Yeah, I know
natural
that.
7.
So can you get it off the calculator? I know e to the 1.8 now. I know that gets me 6. I got a feeling it's a little bit.
1.945, so it's
That's
around
good.
1.9.
1.94. Oh, that's good. So 2.71 raised to that gets me that. Wow. Well, you must have pushed the right button. What did you push? So what did you push? How did you get x alone?
I
Natural log.
typed log natural 7 into
The
Google.
natural log is 7. Oh. So if you want to know what you put on top of e to get 7, you do that with a computer, yeah? Oh, do we have an equation here that equals 36? Do we have 10e to the x over 5 plus 6 equals 36? We have that, don't we? Let's solve that equation. What's my first step?
Subtract 6 from both sides.
Subtract 6. That's 30. So now I have 10e to the x over 5. What's my next step?
Divide by 10.
Divide by 10. So I now have x to the e to the x over 5 equals 3. What's my next step?
ln of 30 is equal to x over 5.
So x over 5 is equal to, 30. The ln of 30, of 3, right? Excuse me. 10 into 33, yes? And what are we going to get ln of 3?
1.1.
1.1, I gave it to you. It's coming off the calculator. So x over 5 equals 1.1. So what x should we pick?
5.5.
5.5. That's the kind of work we're going to be doing. Okay? I'll let the video show you some other tricks of e to the x. Start putting them in your head. I know Aaron, that was one of Aaron's favorites, right? Well, how long does it take to double something at an interest rate?
Yes, I like the money problems.
You did, I know. Aaron's a big fan of making money, I guess. All right, good luck. Anything else? Oh, we got just a couple more problems here. Anybody able to get the ln of 3 halves? Anybody able to get that? What would I do?
ln
ln
3 times ln 3 plus ln 1/2, maybe?
Not quite. A nice try.
ln 3 minus ln 2.
Actually, that's true. That is true. I like what you just said. I'm not used to seeing somebody say addition, right? But yeah, I mean, yeah, that would work. Right? Anybody think of another way to write 3 over 2?
1.5.
Anybody think of another way to write 3 in this base notation?
E to the 1.1
E to the
over
1.1.
0.7.
How do you write the number 2?
E to the
5.
0.7.
E to the 0.7. What are you supposed to do with exponents when you're dividing?
Subtract.
Subtract 1.1 minus 0.7. Okay, so 0.4. I think it was Joshua. Is it Joshua stated that you could have also said the ln of 3 plus the ln of a half. And that's true, Joshua. 1/2 times 3 is 3 halves. I'm just not used to seeing somebody do additional logs for a subtraction problem. All right, so good for you. Okay, and there was one quadratic we did, yes? Do you have the values here? I don't remember the values. Anybody copy that one down yet? Oh, we'll do a new one. Let's do 5 gets you 100, and let's say that 9 gets you 107. Okay, can you write that equation? Hopefully everybody did x minus 5 squared plus 100. Okay, that gives us that correlation. And when I put a 5 in, a little concept, when I put a 5 in, what do I get? 0 squared. What's the importance of 0 squared?
Nothing.
The minimum, right? You cannot get smaller than 0. I don't care what number you put in here. It's never going to get smaller than an answer of 0 because negatives times negatives are positives. That's why that correlates with that at that place. Okay, and when I put in a 9, what do I get? What do I get when I drop in a 9?
4.
No,
116.
you get 16. You forgot to square. Right? If I put a 9 in, I'm getting 16. Do I want to add 16 to get to 107? No. What do I want to add to get to 107?
7.
So I got to convert that 16 units into 7 units. Now, did you get better at anything today? I feel like I'm shouting at you, probably from lack of sleep. All right, so did some of the questions you asked, I hope you made some gains, maybe came out of the room today doing 2 or 3 things you couldn't do before? Okay, so I'd like to do that periodically, but once you get the worksheets in your hand and you go to the board, well, you can work at your own pace, you know, and I'll just walk around. We'll have students. Oh yeah, we have to learn 2 sentences. Okay, so we got to practice this. You got to learn how to say to your classmates and me, can you help me with this? Okay, that's one thing you got to learn how to say. And the other thing you have to learn how to say is, why, yes, I can. It would be my pleasure. Those are the 2 sentences we're going to use the most on Monday. Okay? We're going to do the COVID shuffle in the door. And that door opens up to another big classroom with boards. Okay, the COVID shuffle is like riding your bicycle and you say, I'm passing on the left. Okay, so we got to figure out how we're not both in the hall and the doorway at the same time. I'm sure we can work that out. Okay, and you're going to find out, I don't know, what rate you're learning, right? The rate at which you learn is going to determine how much you learn. That's a little calculus concept, rate to amount, amount to rate. Okay, so, oh, I have to apologize for the video tonight. They're all archived, and I'm just pulling worksheets out from Google Docs. And I see there's 3 trig questions there. Ignore them. Ignore them. I wasn't going to really highlight rational functions till after midterm, but there's a rational function in there. It won't hurt you to hear me, you know, plow my way through it. Eventually, you got to learn it too. And I don't know. It's a different format today. You know, feel free to let me know if it worked for you or not. But once we get the worksheets in your hand, then the pace you set is going to be the pace you set. You know, how hard you work is going to determine how much you gain. Okay, so is everybody okay? I'm still on here, willing to answer questions or explore some topic further. Briefly though, I got dog detail today. I got the puppy. So she's in her crate, so I got to get back at some point to get her out. All right. All right, so I'm going to sign off. And remember, don't panic on the trig. We haven't talked about the trig. There's some solving equations graphically. I don't think I've even done that with you yet. But you can watch me do the work, try to follow it. And hopefully you're feeling like day 3. We still haven't gotten to day 4. You know, and I think magic happens on day 4 with a lot of problems. So hopefully you're feeling like, oh, you know, I'm picking up some things. Okay? All right, so you're free to go and take care of yourselves, all right?
All right, thank you.
I'm still here.
Thank you.
Bye-bye now.
Thanks.
Thank you.
All right, we'll
Thank
see you
you,
tomorrow.
Mr. V.
See you tomorrow. Questions?
Mr. V,
Yeah.
how would you get the the 1.94? How would you get it by hand?
How would I get 1.94 by hand? Can you read? Let me trying to go back.
The e to the 7th is 1.94. E to the 1.94.
I have no idea how to get that one.
Okay, I didn't know either. That's what I was
And
wondering.
that was my point. I mean, there are some things you just got to go to the calculator. Now,
Okay.
I know it's 1.94, right? So I
Right.
can tell you what the ln of 14 is now,
Of course.
right? So Joshua has extended my knowledge. But I think we're going to stick with mostly 2s and 3s so people get the foundation.
Okay, thank you.
Right. You good? Joshua,
Mr.
question?
V,
Yeah.
what is the Laplace transform?
The what?
The Laplace transform.
A transformation, a Laplace transformation? I got never heard of
Yeah.
it. Where'd you
Actually?
pick that up?
No, I was studying I
Matrices?
was studying matrices. There's a section called matrix algebra.
No,
and,
I haven't worked with matrices. I told you, just Kramer's rule.
I've
No?
heard it's
Think
a
of it-
thing in calculus, though. I'm
It
not
might be
sure.
BC. It might be multiple. I think you want to go to Abby Ross. You know, if you want to, so it looks like you're trying to really
Okay,
push your
Abby
way
Ross.
up. Yeah.
Yeah.
Okay, that's great. That's great. Did you ever look at the video on integration and differentiation?
Yeah, I did. It was
Did probably not make a whole lot of sense yet.
I'll look through some
Yeah,
stuff.
I think you should. I think you
yeah.
should repetitively. All I know, my experience with integration was it took me 3 years. 3
3
years
years?
to make the breakthrough.
Wow.
Okay, and I actually came up with exactly what Newton saw, right? But of course, he developed this. I'm working with it, and I'm still trying to figure out how he developed it. And it took me 3 years to get to that square picture, because that's how he actually figured out what the derivative of x squared was. He did a little sandwich theorem of layering, right? And I found that in an archaic textbook in the math department over on the Northfield side, a textbook written, I think, in 1910. I just happened to be looking through it and I went, oh, wow, that's what I saw. And that felt great. Felt great to say, oh, he saw this geometrically because it took me 3 years. I was driving to Charlemont about an hour away from here in my car, driving and thinking about integration. Why is this work? Somehow I got to Charlemont and I didn't kill anybody, right? But I was lost in thought. So very conceptual. Calculus is a very conceptual study. And to really get into it, you're going to have to give it some real deep thought. Okay, but
I will do.
write to Abby Ross and she can give you some direction on that. I can't.
All right, I'll do some more fighting.
Sure. So you
Thank
good?
you.
Okay,
Yep, I'm
see you
good.
tomorrow.
All right, see you tomorrow.
Yeah, bye-bye now.
Bye-bye.
What's up, Seth? I don't have my mask on.
Which room are you in? I thought you were in here.
We're trying to sort out this whole business,
Okay.
right? And
'Cause
they have to set up.
I was hearing you in there, right? I was not
Yeah.
hearing you all the way down the hall.
I'm still in the big science room,
Okay.
right? But the issue is them setting up B block and C block,
Right.
right? And so what we think we're gonna do is go into that far room
Okay.
because it connects.
Okay.
And so I can workshop 9 kids there, 9 kids here, and then they can set up in this room here.
So are you going to be, when you said the far room, are you going to be coming into 101 where I am?
That's the only thing we can think of in solving their problem.
Oh, okay.
I apologize for that because I know you're there.
All right.
I'll make sure the boards are really clean,
Okay.
but your kids will have to wipe down.
Right.
Although I don't think anybody's going to be using desks. They're going to be at the board.
Okay.
And I think you should have your own stash of markers, and I'll take the markers out each day.
You're gonna try and have 9 kids in there on the whiteboards?
I'm gonna give 50 to 100 question worksheets, and they spend 90 minutes at the boards figuring them out.
Okay.
And they're just gonna work their tails off. It'll be a pretty average class one.
Okay.
Yeah, and that way they can set up, because they gotta come in real early. And if both groups are on both sides of the hall, can't do it.
Yeah, okay,
So there are other rooms that are available too, if you wanna switch around a little.
right.
Because I think we're the only ones here.
Yeah.
So I mean, if you wanted to go in the corner room. I don't,
Right,
think-
no, I have 12, and I don't remember the corner they said was only 11 or something.
Okay.
Which is unfortunate. I could do the lab possibly, that's the thing too.
yeah.
Um,
So you might want to use this section of the science thing,
No, I might actually just use the lab. Well, they put up those.
Yeah.
those,
Plexiglass, yeah.
plexiglass, those are great, for
right,
now.
yes,
And I could easily see people using those instead of whiteboards.
sure,
So I might actually, be happy in the lab.
yeah,
Because I can see their work from one kid to the next,
Yeah.
Slightly different pens or something, they can maybe even make it out, so.
yeah. And there's flexibility here because a lot of the rooms are open and
Yeah.
nobody's using them. So, look around, you're just doing D block, right?
Yeah, I'm trying to figure out, so I have I'm trying to think about the spacing.
What about this room?
Yeah, that's possible too.
Yeah.
No, I'm trying to think, because I want to have kids to the board also sometimes, and so.
And Andy's not going to be around here.
I would think that it's only going to be able to fit like 6 kids at the board at any
Yeah.
one time, not all 9 or 12 even. So-
Well, I'm doing groups. So one kid's going to be writing and then 2 kids are going to be back,
Okay,
right? So it's just going to be 3 people writing.
got it.
And that gets me up to 18. Yeah, but I don't think Andy's coming in here very much.
Okay, well, I don't know if he's going to be next week,
Right.
but he hasn't been this week.
He came in A block this morning,
Did he?
and I think he said sometimes he can't get to, I think he does most of his work up at the astronomy huts. Yeah, but yeah, that's the only solution that we can think of
Okay,
so that they can do their setup.
yeah.
Okay,
All right.
appreciate it.